Hello everyone and welcome back to 30 Days of Java. It's day 3 now and today we'll be talking about data types and variables. Our agenda for this video is first to understand what is a data type and variable, what are its types, and how to declare and initialize it. Then we'll also talk about typecasting and finally we'll talk about some points to remember while naming your variables. Now, I know that the terms might sound a bit technical, but stick around because I promise it's simpler than it sounds. And we'll also be implementing these concepts in IntelliJ side by side for better understanding them. So let's begin. As per the official definition of data type, a data type is a classification that specifies which type of value a variable can hold, what operations can be performed on that value, and how the data is stored. Now, this definition might sound confusing for a new programmer, so let's try to understand this in simple terms. In simple words, think of a variable as a named storage location that holds information. Imagine it like a box, where you can keep something, whereas a data type is like a label that tells the computer what kind of data we are working with. As we can see here, the box represents our variable and the cloth label represents the data type, which tells us that this is a box of clothes. Now, if we have two values like a shirt and a sad cat, it would allow us to add the shirt in it, but won't allow us to add the cat in it, since the label on it says clothes. This example is only for educational purposes and no cats were harmed while making it. Let's look at the type of data types that we have in Java. All the data types in Java are divided into two categories, primitive types and non-primitive types. The primitive type of data consists of integer, floating point, character, and a boolean. Integers are further subdivided into four categories: byte, short, int, and long. All of these data types contain integer numbers like 1, 2, 10, 100, etc. The only difference between them is size of data types and the range of value that they can have. Byte data type takes only 1 byte of memory, which is equivalent to 8 bits. Due to its low memory storage, it can only store values from -128 to 127. Short data type takes 2 bytes of memory, which is 16 bits, and it can store values from -32,768 to 32,767. Int data type is the most popular one among them all. It uses 4 bytes of storage values ranging from around -2 million to +2 million. Long, as the name suggests, takes highest amount of memory, which is 8 bytes, and can store values ranging from around -9 quintillion to +9 quintillion. Now, as a developer, it depends on your requirement to choose one of them. If you want to create a program that can handle huge amount of data, then go with long. And if you want lower memory storage, then you can go with short or byte. In most of the cases, int data type is your safest bet and is more than enough for most scenarios. Moving on to floating point, it contains decimal values like 3.14, 5.09, etc. It is subdivided into two categories, float and double. And again, the biggest difference between them is memory storage and decimal precision. Float has a size of 4 bytes, whereas double is 8 bytes in size. Also, float can store decimal values with precision of 7 decimal points, whereas double has a precision of 15 decimal points. A character or char is a data type that can store only a single character. It can be A, B, 1, ampersand, etc. It has a size of single byte. A boolean is another primitive data type that is widely used in many applications. It can only store two values, true or false, and is mostly used when you need to make a decision in your program, which can either be true or false. Coming to the non-primitive data types, there are various subcategories to it, from which 3 are very important: array, string, and enumeration or enum. We will be discussing about all of these primitive data types in future, but for now, we can just briefly explain them. An array is a collection of elements with same data type. A string is a type that represents a sequence of characters. It is used to store and manipulate textual data such as words, sentences, or any combination of characters. An enum, short for enumeration, is a special kind of data type used to define a set of named constants. These constants represent a fixed number of possible values that a variable of that enum type can take. Don't worry if you didn't understand all of it right now. We will be looking deeply at them in future videos. The syntax for writing a variable is very simple. If you are only declaring a variable, then just write the data type and then after a space, type in the name of the variable with a semicolon at the end. The semicolon in most of the programming language is also known as a terminator, which marks the end of a line in a Java code. So don't be confused if you use the word terminator in future. If you want to declare a variable and also initialize it with some value, then we can go with second syntax, in which we add the value after the equal to symbol. Now let's see all of this in action. First, let's start with defining a few variables for different data types. Starting with short data type, short a equal to 1, and then let's define an integer variable that is int b equal to, let's just say 10. Now for outputting them on console, we'll write system dot out dot println and then a equal to a. We'll also be outputting the b value, so b equal to b. Now let's start with running the program first. Run. Here you can see that it's showing a equals to 1 and b equals to 10. That is how we intended it in the code. Now, as we know, a short variable can store a value between 32,000 from negative to positive. So suppose if I give it a value of say 99,999, it would give me an error that says that it is expecting a short value but it's getting an integer value back. Now this is happening because we are overflowing the data value. Let's change it back to 1. Now let's define a float variable. Float c equals to 1.14. Now whenever you're defining a float variable, you need to pass in a character at the end of the value, that is f. Now this f represents the floating point data type. If we change it to d, then this represents a double data type. That is why we are getting an error here, because it is expecting a float value whereas we are giving it a double value back. So let's change it back to f. For defining a character variable, we'll write char d equal to a and then semicolon. Whenever we are defining a character data variable, we need to pass the value in single inverted commas. Finally, let's define a boolean data variable. So type in boolean and then let's just say e equals to false. If we output all of those values in the console, we can just copy this particular line and then paste it again and again, and then type in c d e and then run the program. It would give out the values that we provided in the initialization of the data variables. Now that we are clear with variables and data types, let's discuss about typecasting. Typecasting in simple terms is the process of converting a value from one data type to another. Think of it like changing the form or casting of the data. As you can see in the example below, we are converting an integer type into double type. Let's now try this in IntelliJ. There are two types of typecasting in Java. Implicit typecasting, which is also known as automatic typecasting or widening, and explicit typecasting, which is also known as manual typecasting or narrowing. Implicit typecasting is performed automatically by the Java compiler. It occurs when a data type of lower precision is promoted to a data type of higher precision. As you can see here in the example, that we are trying to assign the value of temperature, which is an integer data variable, to double variable temperature as double. Explicit typecasting is performed manually by the programmer. It is required when a data type of higher precision needs to be explicitly converted to a data type of lower precision. Now here we can see that we are trying to assign the value of a double variable to an integer variable. But we can also see that we are getting an error here, which says that it is expecting an integer value, but it is getting a double value back. So what we can do here to resolve this is just type in the bracket int. That should convert the value of double variable into integer type. Now one thing to note here is that explicit typecasting may sometimes lead to data loss. So suppose if we change the value of 25 here to say 25.903 and then we output the variable temperature explicit using system.out.println temperature explicit, and then we run the program, you can see that we are getting the value 25 back. Now it's not rounding off the value from 25.9 to 26. It would only take the integer part of that value, which is 25, which would lead to data loss. Now some things to remember before we end this implementation is that never name your variable same as a keyword. So suppose if I change the name of this variable temperature as double explicit to, let's just say short, it would give me an error back which says not a statement. Now this is happening because Java compiler is unable to understand the name of the variable. It thinks that you are still typing a data type and you would type the variable name. At last, let's talk a little bit about the naming convention of variables in Java. First, never name your variables same as keyword. As we have already seen in the video earlier, this leads to error and unexpected behavior in your code. So always avoid doing this. Second, give a meaningful name to your variables. Now this is a gray area. When you're doing a competitive coding, then it's okay to use variable names like x, y, temp, etc. But when you're working in a production environment or creating your own application, you should always give meaningful names to your variables. Otherwise, it might become very difficult to understand your code for the next person seeing your code or even yourself in future. Third, use camel case while naming your variables. In most of the production environments, people use camel casing, which is to keep the first character of every word as capital, except for the very first character. As we can see here in the example, number of tables, N is small, whereas O of off and T of table is capital. Fourth, try not to use numbers in your variable names. Java allows you to use number in your variable names, but you should never do that. So try avoiding those rad names like the ones that people used in 2000 on Facebook. Finally, stick with the KISS principle, which stands for Keep It Simple Stupid. Your variable name should be short and simple to understand. Finally, as always, we'll end the video with a quote which says, "We suffer more often in imagination than in reality." So instead of overthinking and worrying about future, try taking action and taking one step at a time. Thank you and have a great day.